Welcome to Belford Academy. Our first flipped classroom video is lesson 7 of unit 6, and we will be determining the equation of an exponential function. Okay, in our first example, we are asked to write an exponential function in the form of y equals a b to the x plus c. That's described by the graph shown. So basically, we're writing the equation to match the graph. Right away, we can see a couple key points worth noting. Hey, watch this to my Star Wars fans. Here is my y-intercept. And when x is 1, y is 5. When x is 2, y is 7, etc. When x is 3, y is 11. Well, we need to use these key points to come up with our graph. So just like when we were first starting to write the equation of a parabola, we stuck to those key points and examined how they had moved about in the Cartesian plane. So step 1, let's create a table of values. Whoops, sorry. Step 1, table of values. And we'll look at 0, 1, 2, and 3. We've already said when x is 0, y is 4. When x was 1, y was 5. When x was 2, 7. And when x was 3, 11. So fill in your chart along with me. So now, in order to determine the b value, we need to examine the change in the y values and see if there's a ratio between each of them. So if I first look at the change in these successive y values, I'm going to get a 1, here a 2, 7 minus 5, 5 minus 4, and finally 11 minus 7, a 4. So we have a change of 1, a change of 2, and a change of 4. Well, 1 times 2 is 2, 2 times 2 is 4, and we can already see that we do, in fact, have a pattern, or we have a ratio that's constant, and that's 2. This is our b value. Okay, so already we know this much has to be true. But there could be more. There could be an a value, and there can be a c value. Let's move to a new slide and we'll keep going with what we've got so far. Okay, so we know so far that y maybe has an a value, does have a b value of 2 to the x plus c. Well, we know that c corresponds with our asymptote, and typically for a regular graph that has not been shifted, our asymptote is the line y equals 0. In this case, we can see that the asymptote has shifted up 3 to the line y equals 3. So just like before, we know that our c value now is 3. Finally, we have to inspect whether there is an a value. We can tell by our table of values that there's not, but let's verify using some key points. So if I plug in a value into my equation for x and y from the graph, for example, 1, 5, we can solve for a. So this point, 1, 5, let's plug it in. 5 equals a times 2 to the power of 1 plus 3. 5 equals 2a plus 3. 5 subtract 3. You get the point. I'm sure you already see. A must be 1. So we're finished. We have just proven that y is 2x plus 3 defines our graph. I just want to add one more point. If we look back at our graph up here, and we see our 0, 4 y-intercept, you know that your asymptote has been shifted vertically up 3 units. If you imagine that this was the x-axis and it hadn't been shifted, when x is 0, no matter what the b value is, 2 to the 0 will give us a 1. And so we haven't theoretically multiplied it by anything if it's still just up 1 from that asymptote. Okay, so that's just another way to see if we have an A value. But trust your math, when you plug in points, it will guarantee it for you. Okay, let's move on to a different example. Okay, in this question, we're given some parameters. We have an asymptote of y equals -5, and we know that we are passing through 2 points, 0, 1, and 2, 31. And we're still writing our exponential equation in the form a b to the x plus c. Now you may be asking yourself, how come we're not defining it by f of x? You absolutely could. We know it's a function. I'm just going with the way the question was written right now. So knowing that I have an asymptote of y equals -5, well, that's my c value. Okay, so already I can fill in part of the equation with -5. But I still need to find my a and I need to find my b. Because I have no graph, I obviously can't create a table of values. 2 points isn't going to be enough to show me or tell me anything. But I can plug those points in just like we did with the a value in the previous question. So I'm going to start with the easiest one, 0, 1. It's my y-intercept, and I know it will get rid of b right away. So let's plug in 0, 1 into our most recent equation. So y is 1. I don't know a. I don't know b. X is 0, and subtract 5. Well, I know b to the 0, of course, is 1. I shouldn't say of course, but we do know it's 1. And subtract 5. So if I bring the -5 over, 1 plus 5 equals a. A is 6. So let's continue to write what we know. Y equals 6 b to the x minus 5. I'm now just missing b, but I have one more point to work with, so let's plug in the values of that point. Y is 31. Don't know b, and x is 2 minus 5. Again, let's isolate the variable, so we'll take the -5 over. 31 plus 5 becomes 36. Oh, isn't that nice? Equals 6b squared. Divide both sides by 6. And I'm running out of room, I'll move over here. B squared equals 6. Now I'll take the square root of both sides. And you might be saying, well, wouldn't that give us b is positive negative root 6? Sorry. Yes. However, remember what we're graphing. We're graphing exponential equations, and whether they're increasing or decreasing, b is always a positive value. It's always greater than 0. Okay, it might be a fraction, it might be a whole number greater than 1, but it's always greater than 0. So we only need to care about the positive value. And we've run out of space. Maybe I can move it up. Oh, look at that. I'm learning as I go along. So finally, let's rewrite our equation with all of the variables filled in. A is 6, b is square root of 6, to the x, subtract 5. And we are done. I've given you a couple more examples that I'd like you to take a look at. Don't spend too much time tonight. Tonight's goal was to watch the video. You might need to rewatch it a couple times. That's great. We will work on these 2 other examples tomorrow, as well as the homework questions I've put on the bottom. Tomorrow will be a work period, but also a great chance to ask me lots of questions and to sit down together and figure this out. I hope you've enjoyed my video. Maybe we could do some more.